Applications of linear systems. In this lesson, we will use a system of linear equations to investigate profits. And also, we will write and solve a system of linear equations from a word problem. The most common system of equations are the cost equation and the return equation. A cost equation details the cost of a business, including a startup cost or a cost of materials, while a return equation details the money the business makes. When the cost equation equals the return equation, this is the break-even point. This is where the business has not gained nor lost money. That means that any value greater than this break-even point value will yield profit for business. Consider this word problem. Danielle opened a bakery. She spent $25,000 on the storefront and $0.25 per cookie. If she plans to sell the cookies for $5 per cookie, how many will she have to sell before she breaks even? Round up to the nearest cookie. So to answer this, we will have to set up first the equations to solve this problem. We will set up the cost function and the return function or the revenue function. So for the cost function, C of x, we have the $25,000, that's the overhead cost, plus the cost per cookie. The cost per cookie is 25 cents per cookie. So you have 0.25 x if x is the number of cookies. And the revenue function or return function R of x is equal to $5 times the number of cookies, because she plans to sell the cookies for $5 per cookie. So $5 times the number of cookies. Now, to get the value of x to have or to reach a break-even point, you would need to equate the two equations. So cost function is equal to the revenue function. Now, the x that would satisfy this equation is the break-even point. So you just need to solve for the equation here. Transpose this on the other side, so you get 4.75x equal to 25,000. And then divide both sides of the equation by 4.75. You have x equals 5,263.1 cookies. So this would mean that to break even, it is equal to 5,264. So we actually round up in this problem because we don't have a 0.1 cookie, and even if, mathematically speaking, it would go down, but since we're counting the number of cookies, then we would have to round up. So because it should be more than 5,263. So 5,263.1 is more than 5,263. That's the reason why we would round up to 5,264. Now, following that same problem, if Danielle sells 6,000 cookies, how much profit will she make? To compute for the profit, we would need to compute first the cost. Now, remember that our cost function is equal to 25,000 plus the cost per cookie, which is 25 cents per cookie. This is the cost function, and this is the revenue function, $5 per cookie. Now, for 6,000 cookies, the cost for that will be 25,000 plus 0.25 times the number of cookies times 6,000, and that is equal to 26,500. Now the revenue, if she sells 6,000 cookies, so 6,000 times 5 is equal to 30,000. Subtracting these two will give us the profit. So 30,000 minus 26,500 is equal to 3,500. Thus, Danielle will make 3,500 in profit. Another example. Claire opens a lemonade stand in a friend's neighborhood due to a potential customer value. However, Claire has to pay said friend $40 to ease the pain of encroaching on her territory. If it cost Claire $0.25 to make 1 cup of lemonade, how many cups does she need to sell at $0.50 per cup to break even? So to begin, we will first define our variable. Our x here is equal to the number of cups of lemonade. Because in the question, how many cups does she need to sell to break even? So let x be the number of cups. Then next is to set up the cost function. Cost function c of x, in this case, is equal to $40. That's the overhead cost, $40 that she needs to pay her friend. And then plus 0.25 because it cost her 25 cents to make 1 cup of lemonade. So 0.25 times the number of cups. That's the cost function. Then next, let's define the revenue function or the return function. The return or revenue function is equal to 0.50 because she is going to sell 50 cents per cup. So 50 times the number of lemonade. Now to compute for the break-even point, you just need to equate your cost function and the revenue function. So if the cost is equal to the revenue or return function, that's the break-even. And then the x that satisfies this equation is the break-even point. So therefore, we have 40 plus 0.25x, that's the cost, equal to revenue, which is 0.50x. Solving for x in the equation here, we have 40 equal to 0.25x. And then you divide both sides by 0.25. And that is equal to 160. This means that Claire needs to sell 160 cups of lemonade to break even. Now let's consider another type of application. This is on solving word problems involving system of linear equations. To solve a word problem that has a multiple unknown values, first assign a variable to each unknown value, and then create equations based on the information given in the problem. And then finally, solve the system of equation using either substitution method or elimination method, and be sure to answer the question in the problem. For example, Jamie needs to purchase tartans for Scottish games between Clan Fraser and Clan Mackenzie. It cost $50 for Fraser tartan and $45 for Mackenzie tartan. If there were 150 total participants signed up and it cost Jamie $7,085 for tartans, how many from each clan enrolled for the games? Now to solve this, we will first define our variables. We will let x be equal to the number of Fraser and y be the number of Mackenzie or from Mackenzie clan. And then we set up the system of equations that will solve this problem. Now, given here that it cost $50 per Fraser tartan and $45 per Mackenzie tartan. And it cost Jamie $7,085 for the tartans. That means that 50 times X plus 45 times Y, because X is the number of Fraser. So 50X is the cost for Fraser tartan, and 45 times, so that's the cost for a Mackenzie tartan, times Y, the number of Mackenzies. And this is equal to the cost, the total cost, which is $7,085. That's the first equation. Also, it was mentioned that there were 150 total participants. So that means if you add X and Y, that is equal to 150. Then we will solve this system of equations here to solve or to know how many of each clan enrolled for the games. We can use elimination method to solve this. We can do that by first eliminating X, and to eliminate X, we will multiply both sides of equation 2 by negative 50. So therefore, we have copy the first equation, 50x plus 45y equals 7,085. And then the second equation, if you multiply it by negative 50, you have negative 50x minus 50y equals negative 7,500. Then add the two equations. So adding the two equations will cancel out x or eliminate x. So we have 45 plus negative 50y is equal to negative 5y, and 7,085 plus negative 7,500 is equal to negative 415. Then you divide both sides by negative 5. Negative 415 divided by negative 5 is equal to 83. So that means there are y is equal to 83, or there are 83 clans or 83 participants enrolled for Mackenzie clan. So then you go back to this equation again to solve for x. So therefore x is equal to, so plugging it to the equation, you have x plus 83 equals 150. So 150, if you transpose on the other side, 150 minus 83 is equal to 67. X is equal to 67. So there are 83 for Mackenzie and 67 for Fraser. United Airlines charges $900 for each first-class seat and $300 for each economy seat on their flight from New York to Texas. If there are 327 seats were sold with a total revenue of $110,100, how many seats from each class were filled? So to solve this, we will first let X be the number of first class seats. And Y be the number of economy seats. And then we will solve, or we will set up the system of equation to solve this. Now, in the given, the cost for each first class seat is $900. So that is 900 times the X number of first class seats plus $300 for each economy seat. So 300 times Y. And that is equal to the total revenue, which is 110,100. Now, it is also given that there are 327 seats that were sold. So that means if you add X and Y, that is equal to 327. Then you proceed to solve for the system of two equations here. To solve this, we can multiply. Let's try to eliminate Y. So let's multiply both sides by negative 300. Then we have 900. Let's copy the first equation, 900x plus 300y is equal to 110,100. And then we have negative 300x here minus 300y equals 327 times negative 300, which is equal to negative 98,100. Then you add the two equations. Adding the two equations, you have 900 plus negative 300x, or 900x plus negative 300x is 600x. And the y cancels out, and that is equal to, so 110,100 minus 98,100, that is equal to 12,000. And then divide both sides by 600, you get x equals 20. So 20 first-class seats were sold. Then you go back and plug into this equation to solve for y. So you have 20 plus y is equal to 327. Y therefore is equal to 307. So there were 20 first-class seats and 307 economy seats were sold.